All right, we are moving into chapter 6. We're going to take off with 6.1 angles of polygons. Now, polygons are two-dimensional shapes that have sides that are straight. So we're not going to have any sides that are curly or wavy. So all of the sides are straight. You know a lot of polygons already. You know a square, you know a triangle, rectangles, hexagons, octagons. These are all different types of polygons. So we're going to review just a couple of things. First, I want you to do is draw a four-sided polygon. So think about it. It must have four sides. They must all be straight. So you could have a rectangle, a square, anything with four sides. And then draw a five-sided polygon. 1, 2, 3, 4, 5. You might know the name of a five-sided polygon already. It's called a pentagon. And then a six-sided polygon. 1, 2, 3, 4, 5, 6. Now it doesn't need to be perfect by any means, just as long as you can see all of the corners. Let's see if I can get some pretty ones going. 1, 2, 3, 4, 5, 6. There we go. That automatic draw. So nice. And then a seven-sided polygon. So we've got 1, 2, 3, 4, 5. That's not going to work. I don't like drawing seven-sided polygons. 1, 2, 3, 4, 5, 6, 7. There we go. That's not really pretty either. Let's try that again. Guys, this is not easy at all. Trust me. 2, 3, 4, 5, 6, 7. That doesn't work either. There we go. Kind of. Anyway, there's my, I'm going to put little knots at my corners. That makes it a little easier to see them at least. And then an eight-sided polygon is an octagon. It's a stop sign, guys. Y'all know what that looks like. Let's see. Dunk, dunk, dunk. Straight sides. Dunk, dunk, dunk. Okay. Again, I'm going to put little knots where those corners are because they are kind of hard to tell. Yeah, doesn't have to be beautiful, guys. So with our polygons, one thing I want you to try is to take your pencil, place it on the vertex or a corner of one of your figures, and draw a diagonal that goes from that vertex to each of the other vertices that are across from it. So on my four-sided polygon, I'm going to start at one corner and go across. And I'm just going from one vertex. I'm not doing every single corner. Now, if I draw a straight line to any of the other vertices in my four-sided polygon, it just becomes a side. If you see there and there. So that's not quite what we're looking for. So you're not trying to redraw a side. So you must go to another vertice that it is not directly next to. So if we do our five-sided polygon, I'm going to pick one vertice. I'm going to go to an opposite corner and an opposite corner. And I can't do the two on either side. If I look at my six-sided polygon, do the same thing. 1, 2, 3, opposite corners. My seven-sided polygon, 1, 2, 3, 4. And my eight-sided polygon, 1, 2, 3, 4, 5. Now, ooh, I do not want this there. Ooh, go back. I'm not trying to draw a shape. I'm trying to. There we go. Now, let's look at these lines that we've just created with our polygons. What do you notice? What do you see that these lines of our vertices create? Well, they create things that all have three sides. What are polygons called that have three sides, guys? Triangles. They are all filled with triangles. Triangles are the basis of all of our polygons, you will come to see. So let's look at this little table we have. If you have a triangle, it has a total of three sides. It's made up of one triangle, and its angles on the inside add up to equal 180 degrees. So let's add to that. A quadrilateral, meaning 4, that is your four-sided polygon, has a total of four sides. let's look at our four-sided polygon up in the top left corner. How many triangles are inside there? 2. And we know those 4 angles will add up to be equal to 360 degrees. If you remember things about squares and triangles, those are squares and rectangles, those are four-sided polygons, and they have a sum of 360 degrees. Now look at your pentagon. How many triangles are inside there? Well, you got 1, 2, 3. And that has a sum of 54 degrees. So if you think about it, 1 times 180 equals 180. 2 times 180 equals 360. 3 times 180 equals 540. So we take the number of sides, subtract 2, and we get the number of triangles. Then multiply that by 180. Take the number of sides, subtract 2, multiply by 180. So there's a trend that we see. If I can follow down my hexagon, I subtract 2, it has 4 triangles. Heptagon, I subtract 2, it has 5, 6, 7, 8 triangles. Did y'all know that a 9-sided polygon is called a nonagon? You're only going to find some really funny words to represent some of these polygons that have multiple sides. Decagon. We'll get to some really big ones that you'll be like, how am I supposed to know that? But it'll be okay. So with each one of these, we're going to multiply the number of triangles by 180 degrees and fill out the rest of our table. So 4 times 180 is 72. 5 is 900. Sorry, guys, it's my parents' dog that is whining for a treat. Or no, dinner. It's dinner time. That's right. And then 1260. And then 1440. So let's think about that, and we're going to talk about some questions here in just a second.